All right, hey, what's going on, guys? I'm filming a little homework problems examples video for you today. We got three problems I'm going to do: number 2, 4, and 12 on your homework, which has to do with section 4 or 5, which is indirect proofs. Another way we can think about indirect proofs is we can call them proof by contradiction. So we're going to find contradictions here to prove our case is good to go. And if you look at this here, you got more than just that to do for homework. You got questions number 1 through 4 all, and questions 10 through 13 all. 8 problems total. Good old Mr. Ford is going to do 3 with you, number 2, 4, and 12. And I'm also going to do them in 2-column form, okay? So you're going to start your written exercises. It says here the directions are write indirect proofs in paragraph form. So if you read the textbook, they've shown you examples about how to write indirect proofs in paragraph form. But the thing in the video that I sent, the lesson video that I sent, is I proved them in 2-column form, okay? So the examples I'm going to do today are going to be in 2-column form. Shall we do them together, shall we? Yes, I think we can. Let's take a look at it here. Okay, so number 2, we're going to prove this one in 2-column form. Remember, this is going to be an indirect proof, otherwise known as a proof by contradiction. So let's see if my lesson made sense and you know the steps in order to prove these things here. I am given this, right? So you got to do the same thing too. This is in the directions for this assignment here. You got to start these proofs. Draw the freaking diagram. Write the freaking given and prove statements just to organize yourself. This is what we need to do. Remind yourself this is what we need to do, and we're going to get ideas as you're writing it out, as you're drawing out of what you could potentially say, which is important because you need to prove something. Also, an academically complete proof includes 4 things. It includes a given diagram that's drawn out and labeled. It also includes the given premises. It includes what you're trying to prove. And then finally, a list of statements and reasons leading from the initial premises to the conclusion here. Okay, so you're gonna do the same thing, copy this out, write the given premise, write the proof statement, and now let's write that proof. Let's do it together, okay? So I'm gonna do it in 2-column form today with you guys. So let me get that here. This is gonna be my statements column, and this is going to be my reasons column. All right, and along with you here, I'm writing out my givens. So this is what I have to work with is I got a transversal T, and I don't need to really write that transversal T cuts lines A and B because I can see that in my given diagram. My given diagram makes that very clear that T's got to be transversal because all 3 of these lines are coplanar and we're meeting at different points. So that means they must be a transversal. So I don't need to write that. So the sort of given premise of this is really that we're going to have a couple angles and they're not congruent to one another. So angle 1 and angle 2 are not congruent, therefore their measurements are not congruent too. Okay, so this means is an inequality sign. It just means it's not unequal. Measure of angle 1 is not equal to measure of angle 2 is how you'd say that out loud, and that's our given premise. Okay, now's the big step here. Do you guys remember what you do in step 2? You do in step 2 what you need to do to prove something must be true by contradicting, right? By contradicting that it can't not be true. What the heck does that mean? Well, watch this example. Maybe you'll get it here, okay? So the idea of this is here, if we know that measure of angle 2 and measure of angle 1, if they're not congruent, then there's no way it looks like that these 2 lines can be parallel to one another, okay? So this is ultimately, we're given angle 1 and angle 2, and there's no sign I can put. I can't mark this up at all because there's no signs for an angle's not congruent to another angle. You can't do that. You can write it out like a statement like that, but you can't mark up a diagram that way, okay? So anyways, given these premises that this and this are not equal to, so I'm not marking up here, there's no way possible that this and this are going to be true, okay? So the way I'm going to prove this, when I'm proving that it's impossible for A and is not parallel to B, if this is impossible for A to be parallel to B, what I need to do is, to start this proof, is I need to suppose temporarily, right? Temporarily assume, suppose that, well, what if A is parallel to B? Okay, what if that's true? And then I'm going to show that it's impossible for A to be parallel to B without these 2 angles being congruent to one another. That's basically how this proof's going to work. Anyways, step 2, what do you do step 2? Okay, that's what sort of basically the idea is here. We need to make a temporary assumption. The temporary assumption is whatever it is we're trying to prove, okay, which is A is not parallel to B, we will assume that the opposite, just temporarily is true. Well, what if, right? What if A actually is parallel to B, okay? And what I'm doing there is I'm doing what's called a supposition, okay? Let's make a supposition. Well, instead of, right, if measure angle 1 is not congruent to measure angle B, measure angle 2, and that's given to us, that's going to lead to them not being congruent. And it's going to lead to not being congruent because let's pretend for a second, well, what if they are parallel to one another? Sorry, I said congruent, I meant parallel. It's going to lead to it not being parallel to one another. And the way we're going to get there is, well, let's actually assume, wait a second, let's make them parallel to one another. There's our supposition right there. We're going to get a contradiction of a known fact in a second here, okay? If I knew that A were, well, let's just say, well, what if A were parallel to B? Then what would connect step 2 to another statement we can make is that if A is parallel to B, we could also say that angle 1 would have to be congruent to angle 2. Well, then angle 1 is congruent to angle 2, and why? And why? So you're kind of reviewing old theorems here, old proofs here. You're getting forced to do that by writing indirectly. And going from step 2 to step 3, our supposition, right? Remember, these lines won't be parallel at the end of the day, but if they were parallel, we'd be able to say that angle 1, and angle 3 were congruent, right? Angle 1 and angle 3, because if two parallel, you got to write this out. You're like writing a proof, right? Writing a proof. If two parallel lines are cut by a transversal, then corresponding angles would have to be congruent. Get me out of the way here. Congruent. Okay? So if the lines were actually parallel, then angle 1 is congruent to angle 3. What else do we know about angle 3, right? We know something about angle 3. Well, angle 3 is congruent to angle 2. Okay, so let's check it out here. Then I could say angle 2 is congruent to angle 3. What's the reason for that? It's not a definition, it's a theorem, and that is vertical angles are congruent. Right? Vertical angles are congruent, which you learned in chapter 1, right? Chapter 1, vertical angles are congruent. So 2 has got to be congruent to 3. 1 and 3 were congruent because we assumed that these lines are parallel, okay? Have we contradicted something? Have we contradicted a known fact yet? No, but we're going to do that in a second. Look, this was our known fact at the beginning. Measure of angle 1 can't be congruent to measure of angle 2. But wait a second. What if we said in steps 3 and 4, we've said that 1 is congruent to 3, and 3 is also congruent to 2. So what are we do? We can bring them all together. Angle 1 congruent to angle 2. Why can we say that? Well, they're both congruent to angle 3. Angle 3. So that's transitivity. Remember, transitive property of equality is if two things, right, angle 1 and angle 2, if two things are each equal to the same thing or congruent to the same thing, then they are equal or congruent to each other, right? Transitive property of congruency here, right? Congruency here. And that's transitive, okay? But what's the problem here? What's the problem in our list of ordered reasons and statements here? What? I've said this. Am I allowed to say this? What? What the heck? I have found a contradiction, okay? So if the lines were actually parallel to one another, then what would follow from that is that angle 1 would have to be congruent to angle 2. But we don't know. We know that they can't be congruent to one another. So our supposition fails, right? Our temporary assumption that A had to be parallel to B is obviously false. Therefore, the opposite has to be true. So what we've basically proven right here is that we've, this step here, okay, supposition fails right here. You don't have to write this in the actual proof. The idea is that you failed, the supposition fails. Everything that followed from the supposition led us to this, and that contradicted a known fact. So now we can say that the opposite of the supposition, which was the opposite of what we were trying to prove, which is what we're trying to prove. What is this here? You're just going to get examples. It's all about must be true. So A must be parallel to B. Okay, and the reason why I know this is that, right, step 5, right, after our contradiction, it contradicts. That's why a lot of people call this proof by contradiction. Contradicts step 1, right, what was given to us, right? Therefore, supposition must be false. Right, our supposition was that A was parallel to B is false, and the original thing we were trying to prove must be true. So A is parallel to B is true. Okay, some sort of summary statement up like that, something like that. Okay, maybe you go back, rewatch this video. I think what maybe it can help, more helpful. So maybe let's do another proof. Let's do another example, right? I'll do 3 of the examples for you in this video, and then you'll have 5 more to give it a shot yourself. Of course, you'll have a Jamboard, but I think this will make sense. You'll read proofs like these here too. It might be easier to write these as paragraphs too. I'm just showing them as 2 columns because I think a lot of people, the feedback I've gotten as a teacher, it's easier for your teacher to go sequentially each step rather than try to write a paragraph. Be like, did I miss something? Did I miss something here? Because I'm trying to show it to all to you right now. All right, number 4, what are we doing with this one? Well, if you're doing this homework, you gotta copy down the freaking diagram. Gotta copy it down, label it up. Right now, the angle 1, angle 2, we're probably talking about those. I don't know. Writing out the given premise, writing out the proof statement. If you've done that, if you spent a minute doing that, then you write your statements and reasons. Remember, you can do it as a paragraph proof. Be like, assume temporarily this is true, show that that's impossible, then you're done. Or you can do it as a 2-column proof, which is going to involve a supposition as your second step. Okay, so let's check it out here. We got our statements and we got our reasons. Statement 1, angle 1. Can you see? I'm not even thinking about the problem. I'm just copying it down, right? Reason to freak out. Be cool, be cool. OJ is congruent to OK. Okay, that's our given premise. Step 2. After the given premise, in an indirect proof, I'm trying to prove this indirectly. Another thing that, again, I said during class, which I really want to call out here, if you're trying to prove something is impossible, like it's impossible for A to be parallel to B, it's impossible for angle J and angle K to be a right angle, odds are you have to write an indirect proof. You have to show that it's impossible for them to be right angles, so we're going to assume that what? We're going to assume that angle J and angle K are right angles, and we're going to show that some sort of contradiction will come up, that our given premises actually would have to be false for that to be true. So therefore, we know our given premises. Those are our gifts from the math gods. Angle 1's got to be congruent to angle 2. There's no way OJ can be congruent to OK. That's not up for debate. So if we contradict those, then whatever we have made earlier, whatever our assumptions were earlier, got to be false. So anyways, step 2 is what? Called the supposition. Let's check it out here. Supposition. And what we're supposing is that what we're trying to prove, we're going to temporarily assume that it's false, that the opposite must be true. Okay, so that would mean that angle J and angle K are both right angles. Okay, so what are we going to do? So we assume that they're both right angles. So I might even mark it up because I'm going to see what follows. Well, if our assumption is that angle J is a right angle, angle K is a right angle, and angle 1 is congruent to angle 2, so you're also marking that up. So maybe I'll do this in red so you can see it a little more clearly, right? So if this is our supposition, maybe the supposition I'll do in yellow because I've been doing that in yellow so far. There and there. So if that's what we suppose is true, and then we know that angle 1 and angle 2 are congruent, we know that's true because that's a given premise. It's given to us from the math gods, there and there. Okay, so now we have 2 angles of this top triangle congruent to 2 angles of this bottom triangle. So then you're thinking, can I use CP-CTC at some point? Can I make some triangles congruent? Can I do it? And it turns out you can prove congruent triangles. Let's look at it now. You can prove it temporarily because of our supposition. Gave us a pair of angles. We have another pair of angles there. What are the reasons to prove triangles congruent? So again, if you had me last year, I had you create note cards, right? You gotta know these 5 reasons very quickly. Please bear with me. If you're new to me this year, try to get those 5 reasons memorized. There's SSS, SAS, ASA, what else? SAA, HL, okay, right? That's it. Okay, so it's not going to be SSS, right? We got 2 pairs of angles. A pair of angles there, another pair of angles there. Could be ASA, but are we really going to be able to prove that JO and OK are congruent to one another? Could be ASA maybe. SAS, unlikely. We don't know anything about sides. AAS, let's see, AA. Was this HL maybe? We know that the hypotenuses are congruent to themselves. We know that OE equals OE. So let's go ahead and add that to the actual proof. OE equals OE. That length OE equals length OE. Not the segments are congruent. So I'm not talking about congruency. Anyways, I digress. What am I talking about here? That's the reflexive property of equality. And it's important I say that because now I've proven if our temporary assumption were actually true, what would have to follow from that is that triangle JOE, Joe, is congruent to triangle KOE. Okay. And reason, is that HL? Is that HL? Well, I have a hypotenuse. Do I have another leg? No, I don't. I have angle, angle, side. Angle, angle, side, right? These yellow ones correspond, these red ones correspond, and then the side's not included. So this is going to be the AAS theorem, right? Then my triangles are congruent, okay? My triangles are congruent. What's the problem with that? What's the problem with that here? Well, oops, I didn't cross this out. OJ and OK can't be congruent to one another. What the heck? What the heck? Wait a second. You're telling me I assumed that these got to be right angles. If they were right angles, then I'd have congruent triangles, and then what would follow from that? Well, then OJ and OK would have to be congruent to one another by, well, these are congruent triangles. And corresponding parts of congruent triangles are congruent to one another. C, P, C, T, C. Corresponding parts of congruent triangles are congruent. And OJ and OK would be corresponding parts of congruent triangles. If that supposition were true, it would follow from that. Those triangles are congruent, and therefore those corresponding parts, JO and OK. Look, we got here JO and KO right there. They're congruent because the triangles are congruent. Okay? So what does this mean? What would have to follow from those two angles being right angles is that OJ and OK would have to be congruent to one another. But wait a second. We were told what at the beginning of the problem? We had an opening premise of this. This premise is here. Okay? And so what followed from the supposition, we have found a contradiction. You don't have to do this little contradiction thing. You just prove it out with 2 steps here. So our contradiction, we've contradicted a known fact that OJ could not equal, right? Could not. I did not be congruent to one another. So that means our supposition is false. Okay, this can't be true, right? This can't be true. So therefore, angle J and angle K, we have now proven it, they can't be right angles. And the reason is supposition has failed because step 5 contradicts a known fact, right? Known facts are sometimes other theorems that might exist out there, but this is just a given premise. So it's either a given premise or a known theorem that gets contradicted. Step 5 contradicts step 1. And there you have it. Okay, there you have it. There you go. All right, so number 12, you got to do this one. I think this is even a B-level problem. Let's check out. I give you some, look at these B-level problems. Yeah, I don't think these ones are too hard later on here. I don't think they're too hard. B-level problems, 10, 11, 12. So those are just 2 A-level problems. I don't think this one's too bad here. Prove that no regular polygon has a 155-degree angle. Okay, so I might draw a generic diagram for this to kind of get this one out. So we got a regular polygon. Okay, so maybe a given regular polygon. An unnamed one because we don't know how many vertices it has. Maybe regular polygon X. All right, we'll just call it X. So X is a regular polygon. Prove. No interior angle measures 155 degrees. Okay, so if I do this 2 columns, I can't really have a diagram of this because it's an unknown number of sides potentially. So let's do this one. Statements. See if I can do this as a 2-column proof. So it might be easier. It's definitely easier as a paragraph proof. Okay, so statement here, X, right? Some sort of figure X is a regular polygon. Okay, that's my given premise of the problem. Step 1, given. Step 2, what's step 2 of an indirect proof? If you're writing a 2-column proof, step 2 would be your supposition. You're supposing whatever it is you're trying to prove, supposition, what you're trying to prove is false. Because then you're going to show something is going to follow that's going to contradict something. So if it's what you're assuming you're trying to prove is false, and then we see that's impossible, then what we're trying to prove must be true. It's like, where is going on here? Man, school, math, this is nuts. Okay, so what we're going to assume is that an interior angle, right? If it's a regular polygon, so an interior angle measures 155 degrees. Okay, 155 degrees. So then your question is here, how am I to get something to contradict here? Contradict a known fact or something obvious here. Regular polygon. Well, then you might be wondering, how many sides? Right? How many sides would that polygon have? And what do we need to know about the numbers of sides here, right? We have a triangle has 3 sides. A quadrilateral has 4 sides. A pentagon has 5 sides. A hexagon has 6 sides. A heptagon has 7 sides. And what am I getting at here? An octagon has 8 sides. A nonagon has 9 sides. A decagon has 10 sides. I don't know what the 11th one is. Who cares? A dodecagon has 12 sides. You gotta love the dodecagon. We don't care about that 11-sided one. We care about that 12-sided one. What am I getting at here? Is there an 11.5 side polygon? Would that make sense? Can a polygon have 3.5 sides? Or we got a triangle, we got a quadrilateral. You average them together. Is that a polygon? No. So here, this anterior angle measures 155. So perhaps what this problem is getting at is 155 going to equal, is there a particular whole number of sides this regular polygon has? So maybe this 155 degrees, we can plug that into the formula of n minus 2 times by 180, and that's over n. That's over n, because this is our formula, the formula that we used back in chapter 2 about the angle sums of a polygon. And angle sum of a polygon is to take the number of sides minus 2, because that gives you the amount of triangles you can make out of the polygon, multiply by 180 degrees, because that's the number of degrees in a triangle. Remember that? You divide by n because you're going to have the same number of angles in a polygon, convex polygon that is, as would be sides, right? As would be sides here. So this is the formula for determining, right? If I knew how many sides I had, like say it's 8 sides, then over here, what would spit out is the degree measurement of each of those angles. And that's for a regular polygon or an equiangular polygon here, okay? So I'm going to plug that in. And my reason for putting this together is, well, this is the formula for the measure of one angle of a regular polygon. Regular polygon. And then I'm going to solve that. Okay, I'm going to see what's going on here. So what I'm going to do is I'm going to multiply both sides by n, right? To get that n out of the denominator. N here times n here. So I get 155n equal to n minus 2 times by 180. So these cancel out. So n minus 2 minus 180, I might as well do some simplification here to make my life a little bit easier. N times by 180 is 180n minus 360. Okay, and what I just did there is technically the multiplication property equality. I multiply both sides by n, so multiplication property of equality, POE. Step 5, I'm going to add, I'll add 360 to both sides. I'll subtract 155 from both sides. So then I get 360 equal to, what is this here, 25n, right? 180n minus 155n is 25n. So then that was the sub and add POEs. Subtraction, and addition property of equalities. And now I'm going to divide both sides by 25 because n, remember, n is the number of sides that this polygon must have that has the 155 degree angles. But remember, we don't want to show that it's possible for a regular polygon to have 155 degree angles. We're going to say that it doesn't exist. So let's see what happens here. Do you want to do to both sides? I want to do my division property of equality, shall we? We should definitely do that. Divide by 25, divide by 25, and check it out here, right? And so now I'm going to figure out what's that polygon. You see where I'm going with this? 360 divided by 25. Wait a second, 14.4? Oh, man, what? And I divided to get that. Division, POE. Okay, but here's a contradiction. What's the contradiction in this one? 14.4 is n. 14.4. What does that connect to again? Remember, how does it all connect? That's what it's all about. Organization, key in geometry. Wait, n is the number of sides that polygon would have. Can a polygon have 14.4 sides? What does that mean? No, there's a polygon can have 14 sides. It can have 15 sides. So here is a contradiction of a known fact that a regular polygon would have to have a whole number of sides. It can't be a decimal. So here, our supposition is going to fail, right? Our supposition is going to fail. So therefore, X was a regular polygon. Let's see here. And what we're going to say is X cannot have a 155-degree angle. And the reason for that is step 6 contradicts. Again, theorem by contradiction. Step 6 contradicts the fact that X would have to have a whole number of sides. Right? A whole number, 1, 2, 3, 4. Technically over 3, right? You need at least 3 sides to be a polygon, so 3, 4, 5. But the idea is a whole number of sides. Can't have 14.4 sides, and that's what would follow from our supposition, that we would have an interior angle of 155 degrees for a regular polygon. Not going to happen, because that would back into the fact that it had 14.4 sides. That's impossible, so if therefore it never had 155 degrees. It has something else here. Okay, I'm going to cut it off with that video right there. You probably didn't watch to the end. Kind of like, hopefully you got it a little earlier than that. Again, write this in paragraph form, right? Make it easier. The way I would do this in paragraph form real quick is that I'd just be like, okay, let's assume temporarily that a polygon does have an 155-degree angle. Well, then using the formula, which I've shown here, I'd show the formula, and solving for it, and then show steps solving for it, that polygon would have to have 14.4 sides. And then you can say no polygon has 14.4 sides. Therefore, there's no way it could have had a 155-degree angle. And you've proven it. You're done, right? You're done for paragraph form, okay? So hopefully by doing this as 2-column form, you can see that you can string together these ideas. You just need to present them now in your homework. Email me if you have any questions. Have a great weekend.